Hello.
Hello.
Yeah, this is Sunny. Are you ready for presentation?
Yes, I am.
Yeah. Before starting, could you say hello to our audience? Wait, I will show you.
Ah, 안녕하세요. My name is Stephen Noble, and I'm an open networking evangelist for Big Switch Network. I work primarily on Open Network Linux and with open networking hardware. I want to apologize for not being there in person, and thank you for allowing me the honor of presenting remotely. Today, we will be talking about open source networking with Open Network Linux, otherwise known as ONL. Okay, so as I mentioned before, today we're going to be talking about open source networking with Open Network Linux, otherwise known as ONL. So what is Open Network Linux and what is it good for? Open Network Linux is a Linux distribution for bare metal switches and other open networking hardware. Open Network Linux is part of the Open Compute project and used by the Open Compute project as a reference network operating system to test open networking hardware. One example of this would be a plug fest, where multiple optics and switch vendors get together to test interoperability of their cables and devices. Open Network Linux is a collection of software, utilities, drivers specific to open network hardware. Like other open network operating systems, Open Network Linux installs using the Open Network Install environment. So, Open Network Linux is a collection of software packages, utilities, and drivers specific to open network hardware. So here you can see some of the members of the Open Compute project, and the list includes most ASIC vendors and network hardware vendors. There are also many end user members such as Facebook, Google, and SK Telecom. There are many uses for Open Network Linux, including being a reference hardware testing platform for certification. The Open Common Core of Open Network Linux provides shared platform code that ensures consistent results in test coverage for areas such as cable and optic functionality, environmental behavior, and protocols such as SNMP. Open Network Linux is also for a do-it-yourself platform for academic and research projects, such as writing packet forwarding agents. The platform driver code that Open Network Linux provides would be complicated for most hobbyists to write on their own. The pluggable nature of Open Network Linux enables innovation in data plane features and network designs. And finally, Open Network Linux can be used as building block for commercial production-grade software, such as the Switchlight operating system that Big Switch uses, and the FBOSS Wedge solution, both of which are built on top of Open Network Linux. So why Open Network Linux? Why not use an existing distribution like CentOS? Well, switches are similar to servers, but they're not quite the same. Open Network Linux built on top of Debian, both Wheezy and Jessie, depending on the platform. You would need to create an ONI installer and manage switch-specific hardware, such as fans, thermal sensors, and SFPs. And a la carte availability is an important aspect of Open Network Linux. You can use the entire network operating system or just take pieces. Our hardware compatibility. Open Network Linux is available for over 25 different switches, both OCP and non-OCP designs. It supports x86, PowerPC, ARM architectures. It supports switches from 1 gig to 100 gig. We recently reintroduced our first non-Broadcom switch, the Acton AS5512. It utilizes the Nephos Aries switching ASIC. We have many platform ports in progress, including the Freescale 64-bit reference platforms, Cavium switching ASICs, and platforms from Celestica. In the last few weeks, we released support for the Facebook Wedge 100. Here we see an overview of Open Network Linux and the hardware that it runs on. On the bottom, you'll see the platforms, switches from Facebook, Interface Masters, Acton, Quanta, Dell. These platforms can have different CPUs, sometimes swappable within the same chassis, and miscellaneous hardware such as fans, LED controllers, sensors, power supplies. Even the power supplies can be swappable. And then they'll have a packet forwarding ASIC. Right now, most of the platforms we support are Broadcom, but we're adding others. ONL runs on top of the hardware, providing the special drivers to handle I2C, MUX, management to Ethernet interfaces, and provides an abstraction layer, ONLP, that allows for compatibility across systems. ONL provides support for the Broadcom ASIC using the Broadcom SDK and abstraction layers such as SCI, OpenNSL, and OpenFDPA. On top of the abstraction layers, you will find forwarding software such as Microsoft Sonic, Facebook's FBOSS, the Indigo OpenFlow agent, and the newest one is a company called SnapRoute. Building ONL, it's simple to do, but it involves many parts. First, kernel patches are applied to the different Linux kernels offered by ONL, such as the 3.2 kernel, which is used for most x86 systems, the 3.9 kernel, used for PowerPC systems, and the 3.18 LTS kernel, which provides support for Docker and EUFS. ONL uses the Architecture Infrastructure Module, or AIM, and the Big Code libraries, both open source and available on GitHub. We use these to glue the different modules together. ONL provides a loader, which is a stripped-down system containing a kernel and necessary driver. ONL provides an SNMP agent, the ONL platform and switch libraries, platform-specific software, and a fault daemon. ONL also provides example agents such as FBOSS and Sonic. ONL-specific packages are combined with standard Debian packages to create a software image, or SWI as we like to call it. When the software image is combined with loader and the install script, the final product, an ONI compatible installer image, is created. This is what you would download from our website or would come out of the compile. So I grabbed a screenshot of the Open Network Linux GitHub site. And I just wanted to point out the three main areas. There's packages, builds, and the repository. There are other parts, but we don't have to go in depth with those. Packages contains three areas. Base, for packages that are for all systems. Platforms, for platform-specific packages. And platforms closed, which contains code that is not currently publicly accessible due to intellectual property or copyright constraints. Under base, you have the standard layout of all, any, and architecture specific. Code that you find in any is built for each system, PowerPC, x86, etc. This would be the Linux kernel, things of that nature. Code that is in all is cross-platform. And an example would be Python, Bash, scripts of that sort. Under platforms, you have each vendor split up by the architecture and switches. Each switch is identified with its own EID. An example here, the Acton AS7712. Each platform has a section for the ONL platform libraries, ONLP, and the platform configuration used to create the boot information, such as the grub configuration. These directories are documented in the docs directory and on the Open Network Linux website. Some examples of closed platform are the Dell S4048, the S6000, and other open networking platforms from Dell. So, if you want to modify and build your own ONL, you start with the architecture packages. There's a YAML file you can see here that's under builds that defines what packages are installed. ONL uses a few tools such as ONL Package Manager, ONL PM, and the root file system builder, ONL RFS. There's a make directory, contains the generic make files to build the kernel, platform files, and create packages. Everything ends up as a Debian package, a repository directory, where you can then pick and choose pieces. So the most important part of this talk is probably here. The ONL platform abstraction layer and the ONL switch APIs. The ONL library manage platform peripherals such as SFPs, fans, temperature sensors, power supplies. ONLP is not Broadcom specific. ONL switch is. ONLP provides a full application API. It's fully documented in the header files found in the module directory. You can see, you can see here. Some example calls are reading an SFP EEPROM or getting fan information. You can see how straightforward the calls are. In order to use ONLP, you need to initialize it and start it. Right here are the calls that do that. ONLP depends on two other libraries, a common library and a platform-specific library. The platform-specific library is a boot time link to the ONI ID of the platform. Writing an ONLP driver for a new platform is easy, as all calls are documented in the header files. The drivers can be user space or kernel space. We do prefer user space. And everything, again, is documented in the docs directory. ONL switch. ONL switch brings expanded and uniform platform support. ONL switch will bring OpenNSL support to 12 plus platforms. The picture here is a bit dated, as Axon has been working hard to provide OFTPA and OpenNSL packages for their platforms. If everybody understands this slide, essentially, this is what exists today with a little bit more filled out up here. And then here is what we get with ONL switch. So what is ONL switch? The ONL switch library runs on top of the Broadcom SDK, provides add-on API. ONL switch handles all of the SDK initialization, including lane mappings, warp core programming, PHY, pre-emphasis settings, and finally, ONL switch provides a unified port management interface. Operational and administrative state, link down versus admin down, small form pluggable and state management, automatic PHY programming, on insertion, standardized capabilities, capacities, breakout cable support, 1 gig support. That's pretty important when you're working with some of the smaller switches that have gig SFP. What else does ONL switch provide? All port management is done through a serialized event manager, which avoids concurrency issues. It also decouples the forwarding logic from the platform details. Switch versus platform port abstraction. Cables are assumed to be one-to-one unless they're breakout. Switch ports are logical, platform ports are physical. In addition, ONL switch registers for and posts port event information, such as date changes, operational changes, port admin up, down. Here's an example of how to call a ONL switch. Again, it should be straightforward and as simple as possible. A full list of implemented features is available. We have an appendix that we provide when people are using ONL switch. So, how to get involved? If you'd like to get involved, join the mailing list. You can try compiling the code. If you're really interested, you can try putting a new platform. As my boss always says, feedback is fine, but patches are preferred. We're growing the support for OCP and non-OCP switches, and there are many contributors from outside of the company. You can try adding forwarding agents. Currently, we support FBOSS, OpenFlow, SnapRoute, and Sonic on different platforms. There's more on our website, opennetlinux.org. And there you can find videos, tutorials, precompiled binaries. I would like to say thank you. And that ends my presentation.
Thank you. Could you show me your? Yeah, okay. Thank you very much. Question? We will have a Q&A session. I will show you our questions. I can share my website.
그 질문을요 바로 그 사이트에 하셔도 되고요 아니면 저한테 질문을 하시면 관련돼서 답변해 드리도록 하겠습니다.
이게 없네. 잠깐만요. Wait. 그거 안 띄워놨나?
제가 올렸어요.
그냥 질문하셔도 되고요. 라이브에 있는 거 하나 볼게요. 아, 네.
Hello, I'm coming from KakaoTalk. I have three questions actually. One is it your home or office?
잠깐만요. Can you hear?
Can you hear me?
It's kind of breaking up a bit. If you can repeat the questions as asked, that would be wonderful.
Yeah, question number one was, is it your home or office? 거기서 얘기 좀.
Is it your home or office?
It's my home office.
Oh,
Some
really?
of you may know that I run a nonprofit organization that does work on quagga. I have a significant amount of equipment in my house that's used for that purpose and for fun.
오케이.
Okay.
그냥 한국말로 해주신 게 더 나을 것 같은데 그 데비안 계열의 OS를 선택한 이유하고 나중에 이걸 쓰다 보면 항상 그 스위치 같은 경우에는 업그레이드를 해야 되는데 얘 같은 경우에는 리눅스 기반이면 커널 업데이트 플러스 GLIBC 업데이트 같은 게 다 올라가야 되는데 그런 거에 대한 부분들은 어떻게 생각하고
그
있는지.
부분도 저도 궁금해서 직접 물어봤거든요.
네네.
그 답변이 일단은 얘들은 데비안 계열을 쓰는 이유는 앱겟 쓰려고 이제
앱겟이 안 좋으니까 여쭤보는 거죠.
주시겠어요?
So the
보여주셔야 될 것 같아요.
his question was that the why ONL used Debian Linux.
So that was a choice in the very beginning based on, I think, comfort in the project. The project originally started almost coming up on 4 years ago. And Debian Linux was what was that we were happy with, I guess.
And the second question is how to maintain the kernel version in the Debian Linux. How to upgrade, for example, how to upgrade the Linux, in OpenNet Linux, yeah.
So this is something that I do constantly with our testing system. So one way to upgrade it is to copy a new SWI file over onto the system and restart it. Another way to upgrade it is we're working on scripts that will allow for you to replace parts of it while it's running. There's another thing that's coming, which is the install mode. The install mode allows you to install Open Network Linux directly to the disk. And this is key for platforms like the Wedge and others that require a lot of extra software. So in that case, if you were to upgrade the SWI and restart the system, it would detect that the SWI was new and would write that over the old system. Does that make that clear enough?
And the third question is about is that as you know, when we manage the package in the Debian Linux, we use the apt package manager. So and his question is what's the disadvantage of that package manager?
So I didn't quite get the last part. It was a question about apps.
Yeah, apt manager, package manager. His
Correct.
question was what is the disadvantage when you're using the apt package manager? It's correct.
I really apologize. I'm still not quite getting it. What is the...
제가 질문을 잘 이해를 못해가지고. Cancel the question. Sorry.
물어봐야 되나요? 그 저기 화면에 나와 있는 종이 저희 쪽에 질문한 거. I will share our question. Can you see the question? 보이나?
What if the platform or Linux kernel version are changed? How does this SDK or ASIC supported on this? Okay.
Yes.
So ONL ships with a couple of different kernels. As I mentioned, we have the 3.2 kernel, which is pretty standard across other NOSes too. We ship with the 3.96 and the 3.18 kernel. And we shipped the necessary modules to interact with the ASIC with each of those kernels on the system. So if you go on to a system and change the kernel that it's using, when you restart, the modules will be there that are necessary for running the SDK, OpenNSL, and the same will be true for other platforms. If the ASIC changes on a platform, I don't know that that's a true, I believe there's a 5712 that has a Cavium processor. I haven't been working with it, but there would be some sort of identifier in there that would trigger us to install the correct software on it.
Thank you.
Thank you. Yeah, I think this is the end of our session. I really appreciate your presentation at night. Thank you so much.
Thank you so
Oh,
much.
no problem. And again, I apologize that I wasn't able to make it there. My travel plans got very messed up, as some may know. Thank you again.
네,
Thank
큰 박수
you.
부탁드립니다.
큰 박수를 부탁드립니다. Bye. Bye.